So then, finally, for the magnetic force, we can say the following. The total magnetic force on this object, as we said, it can be written as a sum, right, over chunks of the current density in each chunk times the volume of that chunk crossed with the magnetic field measured at the location of that particular chunk. This is what we have been saying here so far all along. In fact, this result, I believe we should be able to find it pretty quickly. That was right up here, right? This is where we had basically started, where we had defined this sum on QI VI quantity that we've been evaluating. Once we have it, we take the cross product with the magnetic field, and then we add that up over all of our chunks. So that's what I'm expressing to you here. And then finally, of course, we're going to take the limit as promised that the volume of my chunks should always be going to 0. And I add up all of these contributions. When I do that, then I get two different results. Depending if I'm thinking about wires or more solid systems, I either conclude that the total force is obtained as a volume integral, dV, right? So volume integral would be 3 integrals. You then have J at each location R times the, remember this becomes the current density of the chunk times its volume. In the limit, of course, that volume becomes dV. That has to be taken with the cross product of B at the location of each chunk and added up using my integral. Now, of course, we usually like to write dV at the end of the row, right, when we write an integral. dV is just a scalar quantity, so I can safely move it past the magnetic field without worrying about flipping any signs or anything exotic like that. So this then would just give me triple integral of the current density at location R cross product with the magnetic field at that particular location, and then that whole quantity just integrated times dV. For the case of a wire, which is probably the more common case that we'd want to think about, we know then that the total magnetic force we can get by replacing this sum of J delta V with our other relationship, which you recall is just the current times delta L of the chunk. And then that gets cross product with the magnetic field at the location of the little chunk from the wire. And when I do that and take the limit so that I form an integral, the sum becomes the integral. I then have the current. And I have to be very careful. I can't pull the dl to the front because now it's a vector that's involved in a cross product that would flip my signs. So it would be I dl cross B of R. And those then two are my general formulae for the total magnetic force on an object in terms of either current densities or just straight in terms of currents.